Hi guys, we are talking about Git today, and this is mainly used when you're sharing code with your teammates or friends. So I remember in college when we were working on a project, we used to actually send emails to each other with the entire project archived as a zip, and then try to figure out what are the changes in the new version, keep a lot of versions saved with us. And the worst thing was we never knew what the person has changed and whether we have changed that same piece of code too. So if you're working on a.java, let's say, and your friend is also working on the same project, then you have two different versions of the same file. Now, what you can do to get rid of this is something picked up from multi-threading in computer programming. One person works on one file at a time. But when this happens, all your teammates are stuck till you have completed your job for this file. And when you're done, you share it with all your friends by email. But there's another problem in that. What if your project is really big? What if it's 30 MB in size? Every time uploading 30 MB to each of your friends seems a little impractical. What you really want is a specialized software for this kind of use case. So the second way, which is the smarter way, is to actually have a central computer called Origin, which is going to store all the code of the team. Now, everyone has their local copies, and if a new person joins the team now, all they need to do is fork or clone this project to their local computer. So that will be another copy, their own local copy. They can make changes to this copy whenever they want to, and once they're done, they can send these changes to the central computer again. And so in this way, everyone is at par. Everyone knows what the other person is doing, and their code is not outdated. That's the main reason why we have Git. So now let's imagine you're the fourth person in this team tasked with actually working on the central code that you can see. The first thing you want to do is make a copy of this file. So you download the copy here, download the copy in your local machine, and you have a copy now. Then what you want to do is make some changes. So that's some changes that you have here. After you make these changes, you might want to review them because your entire team may or may not agree with your changes. Therefore, there will be some checking that you do here. And once you're sure that your changes are good, you push them to the central repository. So what's happened now is that this central repository has changed one version. Right? So the central code will go on changing in this way. Different people will be downloading their own copies, making changes, checking them, and then pushing on to the central code base. So the way you do this in Git is you have an origin, which is basically the central code that you have. You want to download a copy, simple command, git clone. What you get now is a local copy of all the code in the central repository. So this is your local copy, and the pointer that you have over here is called master. So this is like a copy of all the copies in the origin. So usually your team is working on multiple features, and each of these features will have a copy of the code in the central repository. So master is the copy which is the most important one because this is always ready to be pushed into production. This is the copy which actually gets you money. Okay, the copy that everyone trusts. What you want to do is be a little safe, and if you're unsure that your code is going to work, you want to make a new pointer to it. Let's say you have the new pointer XYZ. Now this is your branch. So the command for that is git checkout -b. Okay. Let's make some changes because that's why we're doing all this. So after you have made some changes, this is not a git command, it's just changing files. What you can do is find out the status of your new version by using git status. Once you have found out what the changes are, you might want to add some files. Okay, this is basically choosing files that you want to lock down later on. So that's git add. Git status and git add are probably the most commonly used commands, and you'll be using them extensively. There's another command which you'll be using after this, which is git commit. So commit basically locks down all the changes you have made from this point to a new point. right? This is in the graph, this is like a new node. And you see what happens once you do a commit is that XYZ, instead of pointing to the master copy, starts pointing over here. So XYZ is almost like it is like a log line. When you make a commit, it's not copying the entire version into something new. All it's doing is just taking differences from this to this. Okay, and in fact, there's a command called git diff, which tells you what the difference is from this point to this point once you have made the commit. Meanwhile, you have a different team member doing the exact same things. So they clone the project onto the local, they make some changes, and once they're done, they push all the changes to the origin. So what's happened now is that the origin is ahead of the local copy that you have by, let's say, 2 commits. So this is where the new origin is. Now you have made your changes. Let's say you made a few commits yourself, and now you want to actually complete your task. So you want to merge these commits with master, right? You want to change the status of master. But before you do that, the wise thing to do is to leave these commits over here, come back and look at master, look at the origin, and look at the master. So if you see any difference, you'll see that there are 2 differences over here, 2 commits over here, which you haven't got in your local copy. What you then want to do is pull these changes. Git pull, an extremely important command. In fact, pull is always less risky than push. So what's going to happen is master is going to get to this state, which is basically pointing to this state, right? Your local copy starts pointing, master starts pointing over here. Okay, so your local copy of master is the latest copy, but of course you see that your branch XYZ now is not having these commits inside it. Now, one thing that you can do is directly push XYZ to master, but that's not a wise thing because, like we said, master is a pretty important branch. You want to pull these commits over here. The command for that is merge. By merge, what we mean is that, so you get a new pointer then for XYZ, which is over here. By merge, what we say is that whatever changes have happened here and whatever changes have happened here need to be consolidated. So sometimes you need to manually figure out which line of code you're going to actually accept, okay, during the merge command. If things go well and you have merged it really well, this point is probably the most important point in the coding process, because all the changes you have made here are current with the master and they also contain everything that you wanted to change. So your team is going to review your code over here, and if there are any changes that you need to make, you might make some more, but basically this is an important point. Now what you want to do is make master current with your branch changes, because these are changes which have been accepted by the team, and therefore master will be merged with your branch. At this point, you can take your branch and throw it in the dustbin. It doesn't really matter because master has all your commits. So this is where master is pointing now. And finally, your local copy is the copy that everyone in the team wants. So this should be pushed, git push, another extremely important command, to the origin. And what you're now seeing is that you went ahead, made your changes to the most important copy in the team, while other people are also able to do the same thing, and you still have copies which everyone agrees on. So the biggest advantage of this is that you see this entire graph and you see the nodes over here. Each of these nodes is now reachable. You have this copy of code which is accepted by the entire team, but whenever someone downloads this copy now, they actually have records of each change. This one, this one, this one, each change. And they can go to those copies. So in case things fail, you can always go back to this copy. You can always go back to this copy, and so on and so forth. Not only that, you can also understand who has made these changes and then go and ask them why they have made those changes. All of these changes are reversible. All of them are just pointers in a graph. So whenever you have these branches, whenever you are making these commits, they are not entire new versions of the code. So it's not going to take you 10 MB plus 10 MB like it used to for me when I used to send those emails. This is just a tiny difference, another tiny difference. So any node is reachable. So you can revert your changes, which is actually a git command. And finally, with all this flexibility comes the assurance that this code is properly reviewed. And now the new master code. So that's it for Git. If you have any doubts or suggestions, you can leave them in the comments below. If you want any notifications for further videos which are coming out soon, you can subscribe. And until next time, then see you.